So, you want to be an astrophysics major. Maybe you spent your night staring up at the stars. Maybe you watched documentaries about black holes, neutron stars, or maybe even watched some great films like Interstellar.
We used to look up in the sky and wonder at our place in the stars.
And you thought, that's it. That's what I want to do. Astrophysics is probably one of the most fascinating things humans have ever decided to study. Think about it. You get to ask questions like, what's inside of a black hole? What's dark matter? How did the universe begin? And are we alone in the cosmos? These are some of the biggest questions humanity has ever asked. So if you're thinking about doing astrophysics in college as your major, this video is for you, because we're going to talk about what it's really like to be an astrophysics major in college. I am currently one. I'm going into my junior year, and I want to give you a roadmap of what classes maybe you're going to be expecting per each semester. I also want to tell you about what career opportunities you might get outside of graduating or while you're still in undergrad. And hopefully by the end of this video, you'll have somewhat of an idea if astrophysics is for you, if it's the path you want to go down. So before we talk about classes, careers, and whether this major is right for you, there's some pretty big questions that we need to answer first. What actually is astrophysics? Because if you ask most people, they're like, oh, it's the study of stars. And yes, that's a part of the story, but there's even more. It's the study of the universe using physics. The goal isn't just to look at the stars, but it's to understand how they work, why they work, and all the other interactions around them. Imagine the scenario. You're looking up at the sky and you see a twinkling star. For most people, they just see a twinkling star. And that's awesome. It's beautiful, it's bright, it's like a diamond in the sky. But for an astrophysicist, they see a giant ball of plasma held together by gravity, producing energy through nuclear fusion and evolving according to the laws of thermodynamics and quantum mechanics. Same star, very different perspective. And that's what astrophysics is. It's looking through the universe and actually asking, what's actually going on here? Questions like, why do stars shine? Why do galaxies rotate in the way they do? How's a black hole formed? And a very interesting part of astrophysics is this is a science where we can't actually go out and grab something and bring it back to the lab as easily. I can't just pluck a black hole out of the universe, put it in a lab, and study it. This science depends a lot on light. This light contains data which tells us all about the object at which we're observing. The motion of the light can tell us if it's moving away from us or towards us. Brightness can tell us about its energy. The color can tell about its temperature. Which is kind of crazy to think about is we are able to look at pinpoints of light in the night sky and be able to deduce all the physics which is going on with it. And to answer these questions, we're going to need some specific tools to help us get there. Physics, math, computer science, all of these are going to be crucial to our understanding of what's going on. In other words, astrophysics isn't just looking at space, it's being able to apply physics to space and understanding it through that. Which means before you get to go start studying black holes, general relativity, all of this, you're going to be spending a lot of time learning all these tools to build you up to the point where you can study these complex mechanics. So for my first semester as a freshman, my schedule looked like Intro to Physics 1, which is like Newtonian physics. I also had the lab, which was associated with that. We just did experiments. I then had Calculus 1, and I also had to have a Gen Ed. But you might be thinking to yourself, that doesn't sound like any astronomy classes. And that's true. My first semester, I had none. I was working at building up the languages and tools which helps apply to the astronomy classes so I can understand it better when it comes time to take it. My second semester of freshman year is when I had my first one, and that was the Evolving Universe. It's like an intro astronomy class. It was awesome. My schedule then also had Intro to Physics 2, the lab that's associated with it, Calculus 2, then it was the Evolving Universe. So for sophomore year, my class schedule looked like Modern Physics, Oscillations and Waves, which was a physics class. I also then had Calculus 3. I had a seminar class. And then I had my first higher level astronomy class, which was Stellar Astrophysics. Basically like understanding how stars work. Where this semester of astronomy I felt like a lot harder. We had to utilize more math concepts like integration. We had to derive problems. It was phenomenal. It also required some coding, where we had to code a numerical method to help analyze specific data. Then for my second semester, I had linear algebra, theoretical physics, Stellar Astrophysics 2, and then I had a coding class. And so the Stellar Astrophysics 2, this was basically just the second semester of that Stellar Astrophysics 1. So we were learning all about stars. We did coding to help simulate the interior of a star and learn data from it, what was happening at each stage of its life. So I don't know if you noticed a trend so far. Math is a very big deal. You're going to be doing a lot of math inside this major. You go through all the calculuses, Calculus 1, Calculus 2, Calculus 3. As well as you go super in depth in them because they're going to be so pivotal to understand how certain complex processes work in astrophysics. As well as I've taken linear algebra, which I thought was pretty cool. I also plan on taking differential equations, and then I'll probably take some statistics class as well. Math might seem intimidating, but the more you do it, I wouldn't say the easier it gets, but the less intimidating it becomes. Because you understand it's just a process. Once you learn it in one way, then you can just keep following the same path. I definitely struggled at math at first quite a bit, but thankfully, the more I've been doing it, the better I've been getting at it. So for the rest of my projected undergraduate degree, so for junior year, this coming semester I'm going into E&M, so electricity and magnetism. I'm taking an observational lab. I'm taking an exoplanetary astronomy class, as well as I'm taking a philosophy class. That's just another gen ed requirement. And for the other main physics classes I'll be taking for the foreseeable 3 semesters after this, I'll take E&M 2 most likely. I'll take Quantum 1, Quantum 2, as well as there's a galaxies astronomy class I'll be taking, and general relativity. And then I'll have to sprinkle in some gen eds, of course. But for the most part, that's going to be my classes laid out until I'm graduating. But what do astrophysicists actually do after they graduate? Like, what is the career that they're going to be doing? With just getting your bachelor's, you could look at doing data analysis, software development, programming, research assistants, laboratory tech, or you can even go on to get your PhD, a higher education. And if you get that, you could look at becoming a professor, doing research, observatory scientist, and there's so many more opportunities than that. Also, while in undergrad, you might be able to find opportunities as well, such as helping a professor with research. Perhaps your school has a planetarium or observatory you can help and work at. The best way is just to ask your professors what's available for you, if there's any opportunities that can be had. One of the key things that this degree teaches is problem solving. So for things to think about, if it's a good fit, you're curious, you want to learn more. You enjoy learning, you enjoy solving those hard problems that make you want to hit your head against the desk a few times, but eventually you figure it out. You don't mind the math. You don't mind computer science. You don't mind coding. This degree is so fulfilling. Just think of it. The universe is the biggest mystery humanity has ever encountered. Most people spend their lives looking at it. Astrophysicists spend their lives trying to understand it. And if that sounds exciting rather than terrifying, then I think you might just be in the right place.